Apparent brightness is perceived amount of visible light received from a star as viewed from a common location such as Earth's surface, where increasing negative magnitude values are defined to be increasing in perceived flux. Let's unpack this very large definition. Apparent brightness is basically flux, but it's not just flux, it's perceived flux. So you need to understand what flux is. Flux is the amount of light that leaves a star and falls on 1 square meter on Earth's surface. So if you basically draw out a 3-foot by 3-foot square on Earth's surface and you take a look at a star in the sky, you want to find out how much of that starlight lands on that square. That's what apparent brightness is. But it's apparent, so you're basing it on your eyes. How bright do these objects appear in the sky to you? So let's take a look at some of these objects in the sky. Here we have an image. It was taken by ESO, and we're looking at various different objects in the sky. We see this Beta Trianguli Australis down here in the bottom left. We see Alpha Centauri here in the middle left. Beta Centauri is to the upper right of that. To the upper right of that is Beta Crucis, and below that is Alpha Crucis. So Alpha Crucis and Beta Crucis are in the same constellation. Alpha Centauri and Beta Centauri are in the same constellation, and Beta Trianguli Australis is in its own other constellation. So they each have apparent magnitude values in the V band listed. V band is the visual band. It's the band that your eyes see in. So we list little small m means apparent magnitude, and V means in the visual band. And we have all these numbers listed here. So this brings in the last part of the definition. It says, where increasing negative magnitude values are defined to be increasing in perceived flux or otherwise increasing apparent brightness. So if I drew a scale here, and I say these are negative numbers, and this up here is positive numbers. So I have a vertical scale going with negative numbers going to the bottom and positive numbers going up, and we just put a 0 somewhere in the middle. Then anything going down is going to be very bright. So we label this very bright at the very bottom. The more negative the number, the brighter the object appears to be in the sky. The more positive the number, the dimmer the object appears to be in the sky. It seems counterintuitive, but that's how they assigned it way back in the days that they assigned it. So we just go with it from here. The brighter the number, the more negative the number. So positive values would be pretty much dim stars, and negative values would be bright stars, but most stars are going to be in the positive regime. If we take a look at this, all of these 5 stars are in the positive regime. We have Alpha Centauri at a value of plus 0.01. The next one in higher value is Beta Centauri at 0.61. The next one will be Alpha Crucis at 0.76. And then the next one will be Beta Crucis at 1.25. And then finally you get to Beta Triangulus at plus 2.85. So these are based on the brightness. So let's take a look at that. Let me erase some of these. Take a look at the brightness of Alpha Centauri compared to Beta Triangulus. Well, you would say in the sky, Alpha Centauri is definitely brighter than Beta Centauri, so you are a Beta Trianguli. So you need to be able to assign these values. Well, somebody went ahead and assigned them for you. They said, let's make Alpha Centauri plus 0.01, and let's make Beta Trianguli a plus 2.85. So Beta Trianguli is going to be much dimmer than Alpha Centauri. Let's take a look between Alpha Centauri and Beta Centauri. Alpha Centauri is a 0.01, and Beta Centauri is a plus 0.61. 0.01 is less or smaller number than Beta Centauri of 0.61. Therefore, Alpha Centauri is the brighter object. And if you take a look at it, Alpha Centauri is indeed brighter than Beta Centauri. And if you look at Beta Centauri compared to Beta Trianguli, you can see that Beta Centauri is brighter in the sky than Beta Trianguli. Now, this is all based on your eyes, so it's your perceived brightness. It's not the true brightness of the light leaving the star because we don't know how far away these stars are. We're only looking at the amount of light that reaches us here on Earth, regardless of where they are in space. We don't care. So it's our perceived values. And the last thing you need to know is that the unit after each one of these numbers is magnitude. So hence you see in the definition the word magnitude in it. It says increasing negative magnitude values. That's what we mean here. The magnitude is the unit. So let's go through this definition one more time. It is the perceived amount of light received from a star as viewed from a common location such as Earth's surface. And all of that we just said, perceived amount of visible light received from a star as viewed from a common location such as Earth's surface, is just the same thing as called perceived flux. This part, we're increasing negative magnitude values down here. Remember, the units are mag. Increasing negative values are brighter than positive values, where increasing negative magnitude values are defined to be increasing in perceived flux, otherwise known as increasing in apparent brightness.